Okay, this video is going to be about phenols. Now, phenols are a benzene structure, like we've seen before. So we've got this 6 carbons in a ring, some delocalized electrons. They've got an alcohol group on them. Now, the alcohol group is quite a cool group when it's attached to this benzene ring. It's got some interesting properties. The first one is that it behaves like an acid. So it can give off a proton. So it's a proton donator, which is kind of lets it do some interesting reactions. The first of these is that it will form salts. You see, when acids and bases react together, they'll form salt and water. We'll see the same thing if we react our phenol, so benzene ring, alcohol group. Let's react it with our base, sodium hydroxide. So we'll get that hydrogen donated, and that gets donated to OH minus. So we'll end up with H2O. We'll have that O minus up there, and the sodium plus will ironically be on bond to that. So we'll have there, this is our salt, and this is our water given off. Should put a plus there. The other thing they'll do, which benzene doesn't do, we've seen, is that it reacts with bromine without a halogen carrier. So when bromine comes close enough, don't need to put that in it, just there. When bromine comes close enough, and we'll look at why in the next little board, but it will become a dipole. It does get induced, so we get a pair of electrons grabbing hold of that bromine, and the pair in that bond going into the Br minus, which gives us put it on the 4 carbon. H and Br. So I specifically put on the 4 carbon, and in the next video we'll see why. So that goes back in, which gives us OH Br plus HBr. But this doesn't stop reacting. If we've got bromine there, we've still got our phenol, just now it's got a bromine on. So another one joins on. And we'll have our OH, another Br there, and a Br there. And there's still a space for another one to join on. So it will carry on reacting until it's added on 3 bromines, and we'll get 3 HBr as well given off. Now, the general equation for this, so a bit of a mechanism there, is phenol will react with 3 bromines. Because every time it reacts with one of the bromine molecules, it produces a bromine attached to the phenol, and it either attaches in the 2, the 4 or the 6 position, and we also get hydrogen bromide given off. So we're going to get 3 of those. So one bromine molecule, so that's 2 bromines covalent bond together, forms one bromine getting attached on and a HBr. Second one, another bromine attached, another HBr, and the third one, final bromine attached and a third HBr. Now we've got to wonder, why does phenol do this? Because we saw with benzene, benzene cannot react with bromine unless it has a halogen carrier. But phenol can. So this OH must be doing something. For that OH, it must be changing it. And what we've got on OH are two lone pairs, and one of those is essentially added to that central delocalized ring. So we get a stronger ring. Sometimes you may see in diagrams a bit bigger and a bit curved to the top. But because it's got now, because it has now become more electron dense, this central ring, when the bromine comes close, the electrons in the bromine, in this bond, they get pushed away towards that. And these ones become delta plus. That bromine becomes delta plus then, and it can be attacked. So phenol, because the lone pair on the oxygen has been donated into the delocalized ring, makes it more electron dense, so then it can create a dipole in our bromine when it comes close. And benzene couldn't do this, couldn't create this dipole. And that is a quick video on phenol.